Hi everyone, welcome to this free lesson on solving equations that are kind of similar to quadratics. It's hard to describe kind of what I mean by this. We will be solving things that look like this or like this. So just as a reminder, pause and try the examples when you are prompted, and there are always free guided notes available. Okay, so the first thing I want to do is I want to show you this. So notice all the numbers here are the same, right? 5s and 6s and stuff. What I want you to do is take a moment, pause the video, stare at the exponents, and come up with what is the pattern or what is kind of the similarity between all the exponents. There is something that all the exponents share in common, but you're going to have to take a moment to pause and reflect. Hit play when you're ready. Okay, so if you have been looking at this, so each of the smaller exponent, the larger exponent is always double the smaller exponent. So if you look at this, this technically has an invisible exponent of a 1 right here. So 1 times 2 is 2. Here's the exponent of 1/3. 1/3 times 2 is 2/3. Here's 1/2. 1/2 times 2 is 1. So this has an invisible 1 right here. And then finally, 2 times 2 is 4. So all of these have that relationship. And when you have that, you can kind of treat these things like quadratics. So what I want to do now is show you how to actually solve these. Now there's more than one way that you can do this. I just want to give a little caveat here before I show you. But I'm going to show you, I don't want to show you too many methods. So there are other methods, and if you find one and you prefer that one, go for it. You can use it. But I'm just going to show you the one that I tend to find resonates a little bit better with my students on the whole. So what we're going to do here is we're going to use a method called substitution. So basically what you're going to do, once you notice that the smaller exponent, if you multiply it by 2, you get the larger exponent, you will want to do this. And what you do is you set, so you create a u equal to the variable with the smaller exponent. So in this case, my u is going to equal x squared. And then you want to square this result. So what I mean is I take u squared. So what that would require me to do then is I have to square this piece here. So what happens if I square x squared? Well, I can just use the power rule here, right? Multiply those together, I get x to the 4th. So the key here, so just to be nice and clear, this is u squared is going to equal x to the 4th. So check this out now. I've got x squared, my x squared's up here. Now I can replace this with u. And then I've got x to the 4th, so x to the 4th is down here, and I can replace that with u squared. So the next thing that you want to do is make substitutions. So the way that that's going to look then, my x to the 4th will now, by this translation, become u squared. And then minus 13, so we didn't do anything to the 13, right? So we leave that alone. We just substituted out this x squared. So this x squared will become u. And then plus 36 equals 0. Okay, so why? Why are we doing this? So now look at what we've got. Before, maybe I had some idea of how to factor this, maybe not. And if this makes you uncomfortable, then what you can do is you can actually just make these substitutions. I have made this something easier to look at and something that I feel comfortable with factoring. So let me clear myself some space, and I would recommend writing this all down if you haven't. So now what I want to do is solve this new equation. So in this case, I can actually factor this as u minus 9 and u minus 4 equals 0. So my two solutions here are u equals 9 or u equals 4. And so that's the first part of this, but remember, u stood for something, right? So now you want to replace u with its original substitution. So now instead of having u squared equals 9, this will be x squared equals 9. And I just replace both of those u's with x squared, right? And so now look at what you've got here. What I have are two problems that I can't solve. How would I actually finish solving these? What would you use? You would use the square root property. So I can take the square root of each side. So I get x equals plus or minus the square root of 9. So x is plus or minus 3. And then x is also plus or minus the square root of 4, which means it's plus or minus 2. So in total, I get 4 solutions, so I'll just write them up here in pink. My x is 3, negative 3, put little commas here, 2, or negative 2. There are all of my solutions. And so that's how the substitution technique works. So I know that kind of seems like a lot, but once you kind of get comfortable with the u, it becomes something very nice to work with. But one thing that's really key with this is you want to be careful with what happens at this step. So I want to show you this one more time before I have you do some examples. So let's do this again. So I'll walk you through this one and do it step by step. So first things first, you want to set your u equal to the variable with the lower exponent. So go ahead and do that first and then hit play when you're ready. So in this case, my u is going to equal x to the 1/3. Now, you want to square your u, so square this thing to see what you get. So if I take u squared, that's going to be x to the 1/3, and I square that. So if I just multiply 2 times 1/3, that is indeed x to the 2/3. Okay, so now I'm ready to make some substitutions here, right? So where I have this x to the 1/3, I can replace it with u. And where I have this x to the 2/3, I can replace it with u squared. So now what I want you to do, pause and make your substitutions and hit play when you're ready. So now I've got u squared minus u minus 6 equals 0. And so this is something we can totally work with. So now factor this and solve it as much as you possibly can. So this will factor as u minus 3 and u plus 2 equals 0. So my two solutions are u equals 3 or u equals negative 2. So if you've made it to this point, good job. And now what you want to do is replace your u with what that original substitution was. So in this case, that is from this part here. Notice that in this line, I no longer have u squared, so I don't really need to use this anymore. We're not going to use this again. We're just going to literally follow the u. So make your substitutions now with your u back to x to the 1/3. Hit play when you're ready. So now I've got x to the 1/3 equals 3, or x to the 1/3 equals negative 2. Now, this is different from the last problem. If I can just turn your attention back to it real quick, let me show you that screen. This was where, well, I'll just highlight this right here. This is what we got last time. X squared equals 9 and x squared equals 4. But that was because of the substitution that we made. So it was totally drawn by kind of how this was written. So for this problem, I had to take the square root of each side. Now, going back to our new problem, here's what I'm left with now. So now you have to think, for this particular problem, how do you finish it? So what is x to the 1/3? It's effectively taking the cube root of each side, so how do you unravel that? Well, in this case, you would take each side to the 3rd. So I'm going to cube everything. And then that's going to get me x to the 27th, or x to the negative 8th. And so that would be your solution. Okay, so now I have 2 examples for you to try that are very similar to those first 2. So go ahead and pause and hit play when you're ready, and make sure you have all those notes from the other examples written out so you have something to follow and kind of think through. Okay, so for this first one, so I want to do the same thing, right? So my u is going to equal x squared. So in this case then, my u squared will equal x to the 4th. So now I can make those replacements. So x to the 4th now becomes u squared. Nothing happens to the 5, and then the x squared becomes a u, and then this is plus 4. So now I can go ahead and factor this. So this will factor as u minus 4 and u minus 1. So then my 2 solutions are u equals 4 or u equals 1. So now I have to go back and replace my u back with the x squared. So now this is going to be x squared equals 4 or x squared equals 1. And now in this case I can use the square root property. So I will get that x equals plus or minus the square root of 4. So x will equal plus or minus 2. Or x will equal plus or minus the square root of 1. So x will equal plus or minus 1. So those would be the solutions for this particular problem. Now to the next one. So now I'm going to repeat this process. My u equals x to the 1/3, so my u squared equals x to the 2/3. So now I make those substitutions. So this becomes u squared minus 2u minus 15 equals 0. From here you should be able to factor and solve for u. So this becomes u minus 5 and u plus 3 equals 0. Okay, and so then u equals 5 or u equals -3. Now from here you want to replace the u back with the original substitution, which in this case u equals x to the 1/3. So I'll make those replacements. This is now x to the 1/3 equals 5 or x to the 1/3 equals -3. So for this particular problem, to finish solving for x, now I have to cube both sides. So I'm going to go ahead and do this in the green. This will be cubed for each side. Oops. And so in the end, I will get x equals 125 or x equals -27. So that's kind of like one type of problem, but there's a lot of different ways that this type of problem can present itself. So hopefully you feel a little more comfortable with this idea. And now I want you to repeat the same process, but this first one will have different exponents, but it's the same idea. And then this next one will have a little bit of something that's a little bit different from the previous ones. So I want you to really think as you try these and hit play when you're ready. So for this first one, so this is a little bit deceiving in some ways because this is 1/2. But remember, this exponent here is actually an invisible 1. So the smaller exponent is the 1/2. So just keep that in mind and make sure you really think through that detail. So what that means then is my u is going to equal x to the 1/2, and then my u squared. So just think about if you actually work that out. X to the 1/2 squared, so 2 times 1/2, that will indeed just give you x. So now you can make those substitutions. So now I get u squared minus 2u minus 8 equals 0. So I can factor this. So this becomes u minus 4 times u plus 2 equals 0. So I get u equals 4 or u equals -2. Now, be careful when you actually substitute this back. There's a little bit of a plot twist here, and if you didn't find it, maybe you want to pause and think about it before I tell you. So you do want to replace your u with your x. This is x to the 1/2. Or, right, so these are both x to the 1/2. But what is the issue? One of these has an issue now. So again, if you haven't thought of it, pause and just think for a moment about what everything here means. So x to the 1/2 really means the square root of x. And in this case, so a square root can't equal something negative. So this is something you just have to understand about square roots. So this is definitely a more advanced topic. So this cannot be done. Not a thing, can't be done, we can just discard it, right? So I don't even have to worry about this one because you can't have a square root equal something negative. But this is totally fine. So how would I finish solving this? Well, to solve this other one, what I'm going to do is I'm going to square both sides. So now I get x equals 16. So notice, you're squaring this because you were taking the square root. Earlier, we actually had x squared, so we took the square root. So there's like this relationship between squares and square roots that you want to acknowledge here. So that would be the only solution in this case. Now for this one. So we're going to do the same thing. So u is equal to x squared, and u squared is equal to x to the 4th. So it starts off very similar to the other problems that we have. So then I've got u squared plus 8u minus 9 equals 0, and I can factor this. So this becomes u plus 9 and u minus 1 equals 0. And so now I get that u equals -9 or u equals +1. So now I replace my u. So my u is now x squared, so I make that replacement. And so now again, you just have to pause and think for a moment. Is it possible that x squared could equal -9? In this case, it is possible, right? You can take the square root of -9. That's not a problem. you just can't have a square root equal something negative. So you might have to just take a second to kind of think about that. You can't have a square root be something negative, but you can have something squared equal something negative. So if I take the square root of each side, so just think about what happens when I do this. So if I take the square root of each side, this will just equal plus or minus 3i. You have to use an imaginary number for this. And I will include a link to a video on imaginary numbers just in case you need to brush up on that. And then for this other one, so if I just take the square root plus or minus, so then I get x equals plus or minus 1. So there's still two solutions, or 4 solutions, just one of them happens to be imaginary. Now, in the event that your class doesn't allow imaginary solutions, well then I guess that wouldn't exist. So it just kind of depends on what's going on in the class that you're in. So now we're going to pivot a little bit here. This is something a little bit different, but it's still actually the same idea. Pause the video for a moment, just stare at the equation, and make your guess as to what u would actually equal. So in this case, my u would equal x plus 3, and it's not really required to figure out what u squared is, because if you just replace u with x plus 3, you'll just end up getting u squared here. So just because of the context of this, you don't have to have a u squared unless you really want to. So let's look at what happens if I actually make this replacement. So every time I see an x plus 3, I'm going to replace it with u. So I end up getting u squared minus 4 times u minus 5 equals 0. So now what I want you to do is pause and then factor this and replace your u to see if you can figure out how to finish this. I bet you can. So if I go ahead and factor this, I get u minus 5 times u plus 1. So I get u equals 5 or u equals negative 1. So now I need to go back and replace my u with the x plus 3. So now I get x plus 3 equals 5 or x plus 3 equals negative 1. So now I can finish this, right? I can just solve for x as I normally would. So I get x equals 2 or I get x equals negative 4. And so those are going to be my 2 solutions. So that's actually all you have to do for that one. Okay, so I have 2 more of these for you if you want to go ahead and hit play when you're ready. Okay, so for this first one, so my u in this case is going to equal 2x plus 1, so let me make those replacements. I get u squared minus 4u minus 21 equals 0. So now if I factor this, I get u minus 7 times u plus 3 equals 0. So then my u equals 7 or my u equals negative 3. So now if I replace my u with 2x plus 1, I get either 2x plus 1 equals 7 or 2x plus 1 equals negative 3, and now I can solve as usual. So I'll go ahead and show you the rest of this. So in the end, I get x equals 3 or x equals negative 2. So for this other one, so now my u is going to equal x minus 1. So let me show you what this looks like when you replace it. So now I have to factor this, which I can totally do. So this is going to be, let's see, 2u, this is going to be 2u plus 3. So it's going to look like this. Okay, so I'm going to go ahead and solve for u. So my u is either going to equal negative 3 over 2, or my u will equal negative 1. So now I have to replace that with my x minus 1. And so in this case, I will have to kind of just mess with these fractions a little bit, but that's okay, we can totally do that. So let's see, if I add 1 to each side, so adding 1 is really the same as adding just 2 over 2 to this. So I get x equals negative 1/2, or if I add 1 to each side over here, x equals 0. And so those are my 2 solutions. So that will cover it for this video. Thanks for watching, and I will see you guys next time.